Now we will solve the same circuit using the Norton's theorem. So using Norton's theorem, the whole circuit has to be converted into one current source and one Norton resistance, which would be connected in parallel with the current source. So currently we would be first finding Rn, or the R Norton. To do so, we will first convert the voltage source into short circuit and then the current source into the open circuit. So as shown over here, we are first finding out the R Norton. So the R Norton value is 13.33 in this case. Now we will be finding out the IN, or I Norton. To do so, first we will concentrate on this node number 1. We will apply KCL at node number 1, and while applying KCL at node number 1, we would consider some current is moving on the left hand side, some current is moving from V1 to down, and some current, that is 4 ampere, is moving towards the node number 1. And so this will give us this equation. Solving this equation further, we get V1 as AT divided by 3. Now we would be finding VTH. To find VTH, again we would consider VTH as V1 minus whatever is voltage drop across this 10 ohm of resistance. So we would be getting this formula. Solving this further, we get VTH is equal to 200 divided by 3. Now since we have already got VTH as 200 divided by 3, it would be equal to 66.66 volt. Rn is also given. Using Ohm's law, we are aware that I is equal to VTH by Rn. So doing VTH by Rn, we get 5 ampere. So 5 ampere is the Norton current that we were finding. So this whole circuit, which was earlier in this shape, is now converted into one current source of 5 ampere, 13.33 ohms of resistance, which is Rn, which we have already found out, and the same is connected in parallel with 20 ohm of resistance. So now using the current divider rule, we are expected to find IB. So IB is equal to I total into RA divided by RA plus RB. This will further give us this value, which would be equal to 2 ampere. So irrespective of the method that we use, either be it superposition theorem, Thevenin's theorem, or the Norton theorem, in all the cases we are getting 2 ampere of the current passing through 20 ohm resistance. Thank you.